Assalamualaikum and hi everyone. Today, in this video, we will explain about the principle of pre-stress and precast technology. Our group, uh, our group consists of Rohazin, Usman, Shamiro, and Afiq.
Okay, now we go for question 1, which is concept and principle of pre-stressing that are being adapted in pre-stressed concrete. What is pre-stress? Pre-stressing. Pre-stressing is the process which concrete element is compressed linearly by steel wire. We apply initial load on concrete structure so that the structure is able to contract or withstand the stress coming due from the load applied. Once the cast concrete has hardened successfully, the end anchorage range are released, and this releasing from the end anchorage will transfer the pre-stress force to the concrete so that the concrete can contract and or withstand with the stress from the load applied. So the pre-stressing can be performed by two methods, which is first method is pre-tensioning. Pre-tensioning happens before the casting of the concrete. So the stress is induced by initially tensioning the steel tendon by using the wire or strand, so that the tensioning process happen. After the tensioning process happen, the concrete is casting. So we can see that in the figure on the right. The second method is post tensioning. The post tensioning is the steel is pre-stressed only after the beam is cast, cured, and attains strength to take the pre-stress. So the tendon then stress and lock with the anchor at the end of the beam, and then this application can introduce the compressive force to the concrete, and the concrete then achieve the required pre-stress strength to counteract or withstand the stress from the load applied.
Okay, next we will move to how pre-stress construction works.
Pre-stressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, pre-stressed concrete is being used. In pre-stressing, the rods or tendons are stretched along the axis and cement is poured. Later, when the tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to loading at the top part of the beam. The principle behind pre-stressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Pre-stressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Pre-stressing is generally done by two methods: pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary.
Okay, pre-tensioning is accomplished by stretching wires or strands that we call tendons to predetermine amount by stretching them between two anchorage prior to placing concrete. The concrete is then placed and tendons become bonded to concrete throughout their length. After concrete has hardened, the tendons are released by cutting them at the anchorages. The tendons tend to regain their original length by shortening and in this process transfer through bond a compressive stress to the concrete. The tendons are usually stressed by the use of hydraulic jets. The stress in tendons is maintained during the placing and curing of concrete by anchoring the ends of the tendons to abutments that may be as much as 200 meters apart. The abutments and the other formwork used in this procedure are called pre-stressing bench or bed. Okay, next is the post-tensioning pre-stressed concrete. Post, which means after. In a post-tension beam, the tendons are stressed and each end is anchored to the concrete section after the concrete has been cast and has attained sufficient strength to safely withstand the pre-stretching force. In post-tensioning method, tendons are coated with grease or a bituminous material to prevent them from becoming bonded to concrete. Another method used in preventing the tendon from bonding to the concrete during placing and curing of concrete is to encase the tendons in a flexible metal hose before placing it in the forms. The metal hose is referred to as shield or duct and remains in the structure. After the tendon has been stressed, the void between the tendon and the shield is filled with grout. Thus, the tendons become bonded to concrete and corrosion of steel is prevented.
Precast concrete and in situ construction method. Okay, so first characteristic is casting. Precast concrete, since it's cast in factory, easy to monitor the mix and weather can affect the process and can cause in advance. For cast in situ concrete, since it is cast in open space, it is difficult to monitor the blend. Weather can affect the process and cannot cause in advance. The next characteristic is quality control. For precast concrete, excellent quality management, and cast in situ concrete is difficult to maintain and monitor the quality. The next characteristic is cost. Precast concrete. If for large building to be built, precast concrete is the most cost-effective option. And for small structure, it in situ concrete is less expensive choice. For time of construction, precast concrete can be rapid speed on construction site, but cast in situ concrete is the speed will decrease. Thank you.
Carbon dioxide and global warming. Where the carbon dioxide came from? Carbon dioxide is generated by factories, oil, electricity use, and even from transportation. What is the result? The processing of a massive amount of carbon dioxide will cause global warming by polluting the ozone layer. From the previous study, Ya Hondong, they are comparing carbon emission of the precast and the cast in situ for construction method. Precast concrete can reduce the carbon dioxide by first, the material used. The overall amount of carbon dioxide emission during the in situ building construction phase was not the same as the projected amount of carbon dioxide emission from the precast concrete product. This was due to the high cost of oil and energy used to power the machinery used to construct the required material. Second one is oil use. When comparing the precast concrete to the factories that produce a range of components such as cement, stone, and steel, oil consumption is lower. Carbon dioxide emissions that were calculated using a 2.2% energy-saving oil boiler for the precast concrete. Next, electricity use. The timber formwork is molded by the plywood and saw timber, and these materials are made up for original pine, wood, and hardwood. Large amount of electricity and diesel is required to shape and manufacture the timber of formwork. The emission of the timber formwork, therefore, consider large than steam formwork that use 100 times for the precast concrete mold. And lastly, the transportation equipment used. The carbon emission of the precast are much lower than the cast in situ. It is found that 1 meter cube cast in situ concrete emits 770 kilograms, while the figure of precast is only 692 kilo, which is approximately 10% lower than the cast in situ concrete. Therefore, global warming can be reduced as carbon dioxide is emitted by the natural process such as respiration and volcanic eruption, as well as by human activities such as land use change and fossil fuel combustion. Since the start of Industrial Revolution, human has raised carbon dioxide level at atmosphere by 47%, and the most critical long-term forcing of climate change is it. Therefore, we can minimize the carbon dioxide emission and help to reduce the global warming by using precast concrete in the modern construction.